Hello guys! Today we are going to learn about the use of binocular microscope, specifically your compound microscope. So a binocular microscope is any microscope that possesses two eyepieces for viewing a subject that needs to be studied at a high degree of magnification. Binocular microscopes are commonly used in educational and laboratory purposes. This instructional video allows the students to actively learn about the use of a binocular microscope through exploring its parts and knowing the use or the functions of each. You will also learn how to use and maintain the microscope, and also we will discuss about the rules of microscopy. Microscopy is the technical field of using microscopes to view objects in areas of objects that are not within the resolution range of our normal eye. So now we are going to talk about the parts of a typical compound microscope and their functions. First is your eyepiece or your ocular lens. This lens is at the head of the microscope and it is where you would view your specimen. Next is your diopter adjustment ring. It is just found below or at the base of your eyepiece and it allows you to focus the individual eyepiece to your eyes. Then next you would have the binocular tube, which is the support of the dual eyepiece. Next is your arm that supports the tube in place over the stage. Then you would have the revolving nose piece or your turret, which would be a part of the microscope that would hold two or more objective lenses and that can be easily rotated to change your power. Next are your objective lenses. These objective lenses are found or located directly above your stage. The objectives are important parts of the microscope, so we would have to discuss it further. And then I will show you the various object lenses and the characteristics of each lens. There are four different objective lenses. The first one is your scanning objective and it is used to pinpoint the location on a slide that you wish to magnify further. It would provide you an overview of the area before you switch to a higher power and it is usually indicated by the color red. Next is your low power objective that would have a 10 printed on it and then it would indicate that they magnify the object 10 times. It is usually indicated by a yellow band. Then next is your high power objective and it is sometimes called your high dry objective. It is useful for observing fine detail such as the striations in skeletal muscles, the arrangement of a conversion system in compact bones, and it is indicated by the color blue. Then lastly, you would have the oil immersion objective. This lenses is designed to be used with immersion oil on top of the specimen. These lenses would have an oil printed on it and they are usually the highest power objective lenses available. It is indicated by a white band. So now let's talk about the total magnification of your microscope. So the total magnification of the microscope is the magnification of your objective multiplied by the magnification of the eyepiece. Confirm that the eyepiece on your microscope are 10x. So your objective, if you're using your low power objective, it would be 10x multiplied by the eyepiece, which is 10. So it would have a total magnification of 100x. Then for your 40x, which is in your high power objective multiplied by your eyepiece, which is again 10, you would have a total objective of 400x. Then your oil immersion would have your 100x for your objective, and then your eyepiece is 10x, so your total magnification would be 1000x. Let's go back to the other parts of the microscope. You have the stage, the flat surface on which the slides are placed, and then on your stage you would have the stage clip, which would be the one that holds your slides in place. Then you would have the condenser lens, which would be to focus the light into the specimen. And then the diaphragm or your iris would have different size holes and is used to vary the intensity and the size of the cone of your light that is projected upward into the slide. Then you would have the illuminator that would be your steady light source, which would be 110 volts that is used in place of a mirror. If your microscope is using a mirror, it would be used to reflect light from an external light source up through the bottom of your stage. Then lastly, you would have your base. It would be the one that supports all the parts of your microscope. So on your base, you would have the power button, and also you would have the intensity control knob, which would be used to adjust the intensity of your light source or your illuminator. Another important part of your microscope would be your focusing knobs. So you have two focusing knobs. The big one would be your coarse focus adjustment, which would move the body tube to produce large changes in your focus. So as you can see, if you would move your coarse adjustment knob, it would create very big movements of the stage. However, you would also have the small knob here, which would be your fine focus adjustment knob that would move your body tube to produce fine or small changes in your focus. Wherein if you move it, you couldn't see that your stage is moving. So to adjust your diaphragm, you would have the diaphragm ring, which would be here at my side. So as you can see, light here, the diaphragm is closed down, so there is less light that comes through the condenser. But if the diaphragm is wide open, the more light comes through your condenser. So keep in mind that the diaphragm should be open just enough to allow the object lens to collect all the light that comes through the sample. Opening the diaphragm too wide allows some of the light to escape collection by the objective lens, and closing the diaphragm too much causes aberrations of the image. For the second part of this instructional video, we are going to discuss the steps on how to use, adjust, and maintain compound binocular microscope. So first, we have to turn on the microscope, and then as a general rule, always use the lowest power objective lens, which is your scanning objective, in order to find your specimen first. On the microscope in front of you, this is the 4 lens that is colored red. So now, let us turn this objective into place. Then, place the specimen on the stage. Put the stage down first before you put the specimen in order not to hit any of your objectives. Then next, notice that the slide is held in a clip on the stage, which is this one, with the specimen that is side up. So the clip is adjustable and it holds the slide firmly in place. So gently pull the clip back and then slip the slide into place on the stage. If the specimen on the prepared slide is not centered over the hole in the stage, make use of the stage adjustment knob. So this is your stage adjustment knob. The top stage adjustment knob moves the slide forward and backward, and the bottom stage adjustment knob moves the slide from side to side. Also note that there are micrometer readings in your to indicate the position of the stage on both dimensions. So it is on your stage. It is found on your stage. This is useful when looking for the exact location of the part of your specimen that you want to focus on. Now that you have the lens in place and the specimen centered over the whole of the stage, you can now gradually raise the stage using the coarse adjustment until you reach a stop. So watch from the side of the microscope to make sure that the lens does not hit the bottom of the slide. So looking through only your right eye, focus by lowering the stage gently away from the lens by using the coarse adjustment knob. So always remember that when focusing to adjust the stage away from the objective lens, never raise the stage while looking through the microscope because you could smash the slide into the lens and ruin them both. So now let us try focusing your specimen with your right eye only. Okay, so next would be after you have found the object with the coarse adjustment knob, you can now slightly use your fine adjustment knob until your specimen is sharp and clear. Okay, so now that you have adjusted and you have already seen your specimen clearly, you can now adjust the binocularity so that you can see, or you can use both eyes to view your specimen. So in order to do that, you can pull them away from each other, or you could put them together in order to until you could only see one specimen with both eyes. So you could only have one circle. You could only see one circle with both eyes. So now that you have already adjusted your binocularity, you could now adjust the focus of the eyepieces. So take note that the right piece is fixed, but the left one has telescoping capabilities. So in order to do that, you have to first cover your left eye or close your left eye, and then look through the right eye once again and bring the object into focus by turning the fine adjustment knob. Then, cover your right eye, focus the specimen with your left eye by adjusting the telescoping knurled knob on the left eyepiece, which would be the one that would have your telescoping capabilities, and then the microscope should now be in focus for you as an individual. So now, in preparing to adjust the light on the specimen, use the stage adjustment knob to move the stage forward, backward, or sideways to get a better view of your specimen. So now, we are going to learn about how to adjust the condenser and the diaphragm to get reasonably good consistent lighting. So the next thing that you have to do is close the diaphragm as far as possible by rotating the diaphragm ring. Try to notice that the light, it doesn't disappear, but rather it would decrease. Then while looking through the microscope, you need to move the condenser up and down until you see a pebbly or curly appearance. So at this point, the light from the lamp is focused on the plane of the specimen. So once that you have found this pebbly appearance, adjust the condenser knob towards you and then slightly until the light disappears and the light appears constant. Like that. So next is that once the condenser is adjusted, open the diaphragm slightly until the light reaches a constant illumination across the entire field. Now that the light is adjusted, you might need to adjust the fine focus again to see the sharpest image possible. And then you have the most modern microscopes, wherein these modern microscopes are parfocal. This means that once the specimen is in focus with one objective lens, only slight turn of the fine focus knob is required when changing to a higher objective. So you should only use the fine focusing knob after adjusting the coarse adjusting knob in one of your objectives. So this also means that when you change to a higher power lens, the lens should not hit the slide. However, just to be sure, always look at the slide from the side while you change from one objective lens to another to make sure that the lens does not hit the slide or the stage. Then, change to the 10x lens by rotating the turret 90 degrees and feel the click as the objective comes into place. Okay. And then you do not need to move anything else when doing this. So do not adjust the coarse focus knob anymore because the slide is now too close to the lens. That movement of the coarse knob could raise the stage enough to smash the objective lens. So now you only need to focus the fine adjustment knob. So there are other adjustments that you need to make when changing of the objective lenses. You might want to recenter the specimen using the two-stage adjustment knobs as you did in your step 8. So you might also need to open the diaphragm a little more in order to see clearly your specimen. Remember that when you change the objective lenses, you do not need to adjust the lamp and do not need to adjust the condenser. And then you do adjust if necessary the focus, the fine focus, the diaphragm, and then also your mechanical stage. Now, you just have to repeat step 12 with the high dry or your high power objective, which would have your 40x. So after doing all that, we are now ready to discuss the 100x or your oil immersion lens. So what do you think is special about this objective? It is special and different from the rest of the objectives because it would require the use of oil between slide and the lens. So why is there a need for us to put oil between the slide and the lens? It would allow more light to be gathered by the objective lens. So in applying oil, I would be teaching you how to apply oil, but I wouldn't be able to demonstrate it because I do not have my oil with me. So first, you need to rotate the oil immersion lens about halfway into place so that no lens is directly over the specimen. Then place a drop of immersion oil on the slide at about point center over the stage, and then carefully rotate the 100x oil objective into place with a click. So from the side, you should notice a flash as this lens enters the oil. So you can see actual connection between the lens and the oil on the slide. So for the highest resolution, place oil on the condenser lens too. Now adjust the fine focus diaphragm, and then the stage as described in step 12. With the 100x magnification lens and the 10x eyepiece, the total magnification is 1000-fold. Note that you will not want to look at every specimen with the oil immersion lens. Why? Because some specimens are too big to be seen clearly at this magnification. Since we don't have any glass slide available, we are going to use a written letter E on a piece of paper. So after writing the letter E on a piece of paper, we are to put it on the stage at the correct orientation of the letter E. Carefully put it on your stage. And then we start to focus it like I demonstrated a while back. So need to put it up or lift it at a full range, and then look for your specimen or focus your specimen. So as you could see, we have placed the right orientation of the letter E on your stage. However, when you look through your ocular lens, you would see an inverted letter E. Now, why is that? So the image is inverted due to the objective lens being convex. It is also seen in larger specimens where the orientation is known. For example, if the head of an insect is directed towards the top of the slide. So the letter E appears upside down and backwards because of the two sets of mirrors in the microscope. This means that the slide must be moved in the opposite direction that you want the image to be. When you are ready to clean up, you need to follow these steps. So first, you need to put the low power objective lens in place. Your low power objective lens. And then lower the stage all the way down with the coarse adjustment knob. And then using lens paper, carefully clean the oil off the immersion lens using the rotating motion as shown like that. So rotation, okay. And then be sure that you would remove all of the oil. So remove the slide and then clearly clean off the slide and the stage using your lens paper or Kim wipe. Never use Kim wipes on your objective lenses. And then after that, you can now turn off the light. And then when carrying a microscope, always use two hands. You need one hand on your arm, on the arm, and then the other on the base. So, like this. So now, we have come to the end of this video. I hope it helps. Bye!